In this problem, we're testing the same exact claim, but instead of using a hypothesis test and the p-value method to make a conclusion, we're going to build an appropriate confidence interval. So the confidence interval that we're building is the confidence interval that estimates the difference between mu1 and mu2, all right? So we want to know what is the actual difference. Now, if the null hypothesis claim is true, then that means that the difference between the two population mean values should equal 0. And if that's not true, then the data should support the alternative hypothesis, which says that the difference between mu1 and mu2 is some number greater than 0, implying a positive difference. Okay, so let's take a look at our sample data. From our sample data, we can see that the sample mean values, 82.8 minus 75.7, has a difference of 7.11. Now, clearly, 7.11 is not 0, okay? So we can see that the difference between the two mean scores is probably not 0. And it does look like it is a positive number. So right now, it feels like our sample statistics does support the alternative hypothesis, but we want to make sure that this difference is real and not just due to the randomness of our sample. So let's go ahead, and the first thing that we need to do is build the confidence interval, by selecting the correct, so what is the correct or appropriate confidence level? What I mean by that is, are we going to build a 99% confidence interval, 95%, 90%? So what confidence level is appropriate? To determine which level is appropriate, you got to go back to your alternative hypothesis here and take a look at the symbol. So notice that we have a greater than sign. Excuse me. The greater than sign implies that we have a right tail test, which means all of our significance level is going to be on the right tail. Okay, when you're building a confidence interval, the confidence interval has to take into account the right tail and the left tail, and the area where our error rate is has to be the same. So on the right is already 5%, but again, like I said, for a confidence interval, we also have to take a look at the left tail, and the left tail needs to be the same as the right tail, so this is going to be another 5% on the left. So what this means is what's left in the center is where I'm going to find my confidence intervals that contain the difference, right, between mu1 and mu2, or the null hypothesis claim. So the difference, if the difference is 0, we should find it at the center of this distribution that I'm shading in black. So what percentage is this shaded area in black? Well, that's 1 minus 2 times the areas in the tail. So the areas in the tail is 0.05. So that means that I've got 1 minus 0.10, which is 0.90. So I'm looking for a 90% confidence interval. So now you can go to your calculator and you can use the function to sample t interval. All right, and you can type in all the data. So you can type in all the data that's given to you in the tables here. Okay, you probably already have it in your calculator from the last problem. And the calculator will give you the following confidence interval. So it will say that the 90% confidence interval for the difference between the population mean values is going to be between 2.378 and 11.847. So notice that this confidence interval, if I draw it on a number line with 0 at the center, this is not drawn to scale, but let's say that this marking here is 2.378 and this marking here is 11.847. Notice that it does not contain 0. So this marking 0 is where mu1 minus mu2 is equal to 0, aka the null hypothesis claim. So because the confidence interval does not contain 0, right, this is saying that we should reject the null hypothesis. Why? Because we are 90% confident that the true difference between mu1 and mu2 is between 2.378 points, and that difference could be as high as 11.847 points. Therefore, the confidence interval actually supports the alternative hypothesis. So you would write out the conclusion the same way. You would make a statement such as, we are 90%, so I'm not going to write it all out, I'm kind of running out of room here, but you would say something like, we are 90% confident that the true mean difference between the two population mean test scores is between 2.378 and 11.847. Since the confidence interval does not contain 0, we are going to reject the null hypothesis and conclude that the data supports the original claim that the mean test score for those who use the courseware is going to be higher than the mean test score for those who do not use the courseware.